Electricity is all around us, in our devices, in our homes, even in our bodies. But what is it, and how does it actually behave? Electricity is the movement of charged particles. In everyday wires, those particles are electrons, tiny bits with a negative charge. When they move through a material, we call that an electric current. They don't just wander around aimlessly. They travel in a loop called a circuit. It all starts with a power source, like a battery. A battery has two ends. Negative terminal, where electrons come out, and a positive terminal, where the electrons want to go. Electrons leave the negative side, flow through a conductive path like a wire, and interact with devices along the way. Maybe a light bulb, a motor, or your phone. They give up some of their energy to power those devices, then return to the battery's positive side. Electrical current always needs a complete path back to its source. Every current in a wire has four main properties: voltage, amperage, resistance, and wattage. They decide how much energy moves through the circuit and how quickly it's delivered. One of the easiest ways to picture this is with a water pipe. Voltage would be represented by the water pressure, or how hard the water is being pushed. The more voltage, the stronger the push. Amperage would be represented by flow rate, or how much water is moving through the pipe per second. The more amps, the more total water moving. Resistance would be represented by the size or restrictions in the pipe. Smaller or clogged pipes resist flow more. And wattage would be represented by the punch of the spray, the total force you feel when the water hits, combining both pressure and flow. In short, imagine electricity as water in a hose. Voltage is how hard you're squeezing the pump. Amperage is how hard the water is flowing. Resistance is the size of the hose, and wattage is how powerful the spray is when it hits you in the face. Electric current flows through every path it can, but most of it takes the one with least resistance. That's why metals like copper are common in wires. They have low resistance, so electricity moves through them easily. Some metals, like gold and silver, are even better conductors. They're used in delicate circuits where you want the best possible electrical connection. When electrons face resistance, some of their energy is released as heat. That's why wires get warm under a heavy load. If the voltage is high enough, electricity can jump through the air instead of staying in the wire. This is called an electrical arc. It's actually a channel of plasma, a superheated ionized gas. Plasma glows because the atoms are so energized they emit light. Low-energy discharges might only appear as tiny sparks or faint glows. This is called corona discharge, and may just last a fraction of a second, but they're still caused by ionized air. Same principle, just different size. Thank you for watching the video. I hope you learned something new today. And if you have questions, drop them in the comments. And if I messed anything up, please tell me. After all, this is electricity explained by a moron.